Greetings, this is Mark Anderson for Kellogg Community College, and we are going to talk about some arithmetic sequences and series and how it applies to some story problems. It would behoove you to look at the two equations that we did in previous videos. The one video talked about a sub n, and that's an equation that we use to find a specific term like a sub n. And another one is the summation equation, which is s sub n. And this first problem is talking about an object that is dropped from a helicopter, and it's following 16 feet in the first second, 48 feet in the second, and then 80 feet in the third. What in an arithmetic sequence? And we know that actually like gravity works not that way. We know that things obviously get faster, but maybe this is a wingsuit or something that would have some lift or loft that would keep it from exponentially getting faster. So just suspending your disbelief there, we want to know what is the total distance the object will fall in 5 seconds. And this total distance is important because this means we will use the s sub n equation. That s sub n equation is going to be then looking for n over 2, and there's my a sub 1 plus a sub n. Now I do want to make a quick note that in this problem, since 3 of the 5 seconds are actually given, it might be easier to just go 2 more seconds by hand and then adding up those 5 seconds. And I totally appreciate the idea of doing this without the formula, but on the test I might actually give something that's longer than 5 seconds, something that would be of like maybe 30 or 40 seconds, so actually doing them by hand would be actually less time, makes less sense because it just is so time prohibitive. So let's actually look at filling out this equation. We know we need to go to our 5th second, so this is going to be 5 divided by 2. Our first term in this sequence is 16, but we don't know a sub n. So we're going to figure out that 5th term by going with our general equation, which is our a sub n plus, and in this case, n minus 1, or 5 minus 1 times d. Now we can figure out our a sub n and d by looking at these numbers here. So the first number is 16, our second number is 48, and our third number is 80. So it looks like we're going to start with 16, our 5 minus 1 is going to be 4, and then our d is going to be 32. It's going to be 32 because that is the distance between these numbers at each step of the way. So 32 and 32. So 4 times 32 plus 16 gives you an answer of 144. Now this happens to be the 5th number in our little sequence. So we're going to go 16 plus 144, which is then going to be 160. 160 times 2.5, and that gives me an answer of 400. And that's right, 400 is the sum of the first 4 numbers. So 16, 48, 80, and then 2 more numbers here, one of them being 144. Doing a quick subtraction here, this would be 112 there. So by adding 112, 144, 80, 48 and 16, you get 400, or by using the formula, you get 400 as well. Alright, so for our second of 3 problems, we have a display of cans in a grocery store. Now I think what's going to help here is to actually draw a picture of this. So we're going to have 36 cans at the bottom of this display, and then the next run above it is 31 cans, and it's going to go up for several more rows until we get to the top row, which has 6 cans. Now this top row is actually the end of our sequence here. So this is our a sub n, and this right here is a sub 1. So what we're going to do is it wants to know is to find the total number of cans in display. The total means we're going to be our s, and in this case s sub n. But we actually don't know how many rows there are. Now it's possible that we could actually go up by this little step increment between these two numbers and keep doing that until we get to 6 and find our s sub n here. But let's actually use the formula to figure it out. It's a little bit more fun, and especially on the test, if I give you a much higher number than, or like a bigger base instead of 36, maybe something over 100 that gets to the top with roughly about the same size as this one. So, shoot, you're going to need to use the formula as best you can there. So we have s sub n. We don't know what our n is right here to divide by 2, But we do know the first term. In this case, the first term is going to be 6, or not 6, sorry, 36, and our last number is going to be 6, which is kind of nice. But we do need to find the n. So to do that, we're going to use this a sub n equation, and we literally don't know what the n or the subscript is down here, but we do know that that number is 6 because that is our last number in our little sequence here. And then this is going to be equal to a sub 1, in that case that is 36, plus the n minus 1. Again, we don't know what n minus 1 is, so we're just going to leave it as n minus 1. And the distance here is going to be negative 5, because we seem to be losing 5 cans as we move up each individual step. So here's my 6 is equal to 36 minus 5n plus 5. So that's my distribution of the negative 5 to these two. So I got 6 is equal to 41. Wow. Yep, 41 minus 5n. If I subtract the 41 from both sides, 41, sorry, that looks a little sloppy there. I get an answer of negative 35 is equal to negative 5n divided by negative 5 divided by negative 5. N is equal to 7. N is equal to 7. So my 7th term is going to be 7 divided by 2, or 7th. Yeah, that's the number of terms it would take me to get to that number 6. So 3.5 multiplied by 42. The answer there is 147 cans. Now again, I could have just brute forced went, 26 and then 21 and 16 and 11 and then get to 6. I mean, I could have added all these numbers up, but this is a great, this is the process of doing the problem. And moreover, if I have a bigger story problem for display, yeah, you're going to need to use that formula. Drawing the picture ain't going to help because you won't be able to do it all the way. And the same thing goes for this problem here. This is a problem where there's an inventory of calculators, and it looks like we're starting off with 12K, and that's on January 1st. Now, when we look at January, that would be 1 on our number line, or like if you were asked to count months by hand and you had 2 closed fists, January would be the first finger up. That would be the thumb. And that then says, on the first day of each successive month, we're sending out 800 calculators. How many calculators were in stock after the shipment on September 1st? So in this case, we're looking for a sub n is equal to a sub 1 plus, in this case, n minus 1 times d. So we're actually not looking for the sum, we're just actually looking for this September 1st deadline, which in this case would be the 9th month. Because if we started to count January as the first month of the year, September would be the 9th month. Now, we start off with 12,000 calculators. We're going to have 9 minus 1, so this is going to be 8. And d, which is the distance here, is going to be negative 800. Now, that would then, if by using that in the calculator, 12,000 plus 8 times negative 800, this goes first, and that's 6,400. Taken away from the 12,000 gives me an answer of 5,600. This is how many we would have at the start of that 9th month in September. And I think some of you are still thinking, yeah, but I could have done all this without this formula. I could have just, put a calendar on and, started off with 12,000 and then just dropped it, until I got to September. Sure, you could have done that, but what if my problem didn't go just, 9 months into the future? What if it went, 3 years, 5 years, 10 years and started with a much bigger number and a much more difficult subtractor? Well, geez, I think you're better off using the formula. So learning to use these formulas for these small problems is great, although I know we could have done alternate methods to have found that. But when you get to the test and I have much bigger numbers, it's best to know these formulas. Well, thank you for watching this video on arithmetic sequences and series and applications.